Okay, so we're going to talk about chapter 2, section 1. And in this chapter, we're going to be talking about sequences. So really, we're going to be talking about the nth term with these sequences. So the two sequences that we're going to have are arithmetic and geometric. So those are going to be the main two sequences that we talk about. So the first one that we're going to focus on is we're going to be focusing on our arithmetic. So we're going to have two sets of equations when solving, and we're going to look at some examples together. So let's look at the arithmetic first. So our arithmetic, let me go ahead and just write this on top. Okay, our arithmetic sequence is going to be an equals a1 plus n minus 1d. Okay, so let's go ahead and explain what these are going to stand for. So this is going to be the answer that we are solving for. So I'm going to put answer. A1 is going to be our first term. N is going to be our nth term, okay? That'll make more sense in a second. And then in this case, D is going to stand for difference. Okay. Difference, oops, forgot that E right there. So with the difference, that's going to be our difference between our A2 minus A1, okay? So let's go ahead and look at an example of what those A terms are going to look like. So I'm going to go ahead and erase this real quick, but make sure you just get all of that written down and that you know those terms. Okay, so let's go ahead and look at our first example. If I can move this up, there we go. Okay, so this says find the 82nd term of the arithmetic sequence. Okay, so arithmetic. Okay, so this is going to be our 82nd term. So that's one thing that we need to look at, okay? And then here are our first three terms. So our first three terms are right there. Okay, and what these are going to be is this is going to be our A1, this is going to be our A2, and this is going to be our A3. Okay, so what we need to find with the 82nd term is that's like our A82. So we need to plug that into our equation. So let's go ahead and write down that equation again. So that equation was an equals a1 plus parentheses n minus 1 times d. So the difference, okay? Let's go ahead and plug in the values that we have. So for our an, that's what we're solving for, equals a1. So a1 is going to be the very first term that we are given, okay? So it's going to be negative 10. And then we're going to have plus n minus 1. N is going to be that total, the nth term. So n is going to be our 82 right here. So we're going to have 82 minus 1. Now we need to find the difference, okay? That difference is a2 minus a1. So if we look at our terms right there, our a2 is going to be 6. We're going to subtract negative 10, okay? So when we look at this right here, okay, when we have 6 minus a negative number, okay, that's going to become positive. Okay, so our difference is going to be 16, okay, because that becomes 6 plus 10, so that would be 16. All right, and then here's our equation, and we just solve from there. So we got to make sure we do PEMDAS. We got to follow that order of operations. So we have our an equals negative 10, okay, plus 82 minus 1 is going to be 81 times 16. Okay, now in your calculator, you can put 81 times 16. And when you do that, okay, you should get 1,296. Okay, you're going to see some big numbers when you do these problems. Okay, now finally, you just need to add that negative 10. And when you add that negative 10, our an is going to equal 1,286. And there is our answer. Okay, so perfect. We just follow and we just plug it into that equation, and that is all we are doing. I'm going to go ahead and change to a ballpoint pen. Let's go ahead and look at the next one. Okay. All right, this one, we're finding the 92nd term of the arithmetic sequence. Okay, so again, to the side, I'm going to go ahead and just write out the equation. So I have an equals a1 plus n minus 1 times d, times that difference. Okay, first thing I'm going to do this time is I'm going to find that difference. Okay, so I'm going to identify what my a2 is and my a1. Okay, and our difference is going to be 19 minus 11. All right, you put that 19 minus 11, you can put it in your calculator or you can do it yourself, but you should get equals 8. Okay, so now let's go ahead and plug everything else into the equation. Okay, so we have an, what we're solving for, equals our first term, which is going to be 11 plus n minus 1. All right, here's our n right here. 92 minus 1 times 8. So perfect. All right, now let's simplify. Let's do our 92 minus 1. It's going to be 91 times 8. All right, so I'm going to put 91 times 8 into my calculator. And I am going to get 11 plus 728. Go ahead and add that 11, and then there is going to be our answer. So we're going to get 739. And there is our answer. Okay, perfect. Let's look at just one last one together. All right. Find the 84th term of the arithmetic sequence. Okay. Big thing, I'm going to find that difference first. So I'm going to do my a2 minus a1. So 31 minus 18. Okay. I'm going to plug that into my calculator. Just make sure I double check I'm right. I'm going to and that's going to equal 13. Okay. Now let's plug it into our equation. an equals a1, which is going to be 18, plus n minus 1. All right, our n is going to be 84 this time. So we have 84 minus 1 and times d, and that's going to be times 13. So I have an equals 18 plus 83 times 13. Okay, I'm going to put in my calculator 83 times 13 because I don't know what that is on the top of my head. So I'm going to do 18 plus. When you do go ahead and multiply those together, you're going to get 1,079. All right, and then you're going to add your 18. And when you add your 18, our an equals 1,097. All right, and there is our answer. So perfect. Okay, that's with arithmetic. Okay, so let's go ahead and let's look at geometric. Okay, when we do geometric, all right, the equation is going to be a little bit different. Okay, we're going to be dealing with a lot bigger numbers here. So I'm going to go ahead and scroll down just so we can have a blank sheet of paper. Okay, so this is going to be our geometric equation. So our geometric sequence equation. So with the geometric one, okay, this one is going to be an equals a1 times r to the power of n minus 1. All right, this one we really have to pay attention to what we have to do first, okay? An is going to be our answer again. A1 is our first term, okay? N is still going to stand for the nth amount. All right, and then this time R stands for ratio. Okay, so for our ratio, that is going to equal A2 divided by A1. All right, and then that's the equation that we are going to follow. So let's go ahead and look at the next part. So I have, let's look at this equation right here. Okay, we need to find the 10th term of the geometric sequence. Okay, so I'm going to go ahead and erase this real quick, and I'm going to write it again up here. So I have an equals a1 times r to the power of n minus 1. All right, I need to identify, okay? 10 is going to be my n. All right, 3 is going to be my A1, 15 my A2, 75 is my A3. All right, so let's go ahead and look at plugging this in. But before I plug it in, I want to find what my R equals. So my R equals is that's going to be A2 over A1. Okay, my second term divided by my first term. So if we look over to the side, that's going to be 15 divided by 3. All right, when we do 15 divided by 3, that is going to be 5. So that is going to be our ratio this time. So let's go ahead and plug that into our whole equation. So we have AN equals, our A1 is going to be 3. So 3 times R, which is 5, to the power of n minus 1. That n is going to be 10. So 10 minus 1. All right, let's go ahead and simplify. We got to do our exponents first. We got to do that 10 minus 1. We can put parentheses so we know that we got to do it first. So 3 times 5 to the power of 9. And in your calculator, you can put 5 to the power of 9. And it's going to be a big number, okay? So now we have 3 times 1953125. Okay, so 1,953,125. Finally, we got to multiply that times 3. And our answer for AN, okay, AN, which is A10, is going to be 5,859,375. Okay. Even if you got to get a big answer, you just got to know with these geometric sequences, they're going to be big answers. Okay. So let's go ahead and move to the next one. Okay. First thing that I noticed in this one, okay, our nth term is 11. Second thing I noticed is, okay, we have negative this time. All right. So we got to pay attention to our negatives and if our answer is going to be negative or if it's going to be positive. Okay. So I'm going to identify this as my A1. All right. This is my A2. I'm going to go ahead and write that sequence out again just so we know that equation and can get it memorized. Because the more times you write it, you're going to figure it out quicker. Okay, so I have A1 times R to the power of n minus 1. Let's go ahead and figure out our R. Okay, that was A2 divided by A1. Our A2 value this time is negative 18, and our A1 value is 6. So we're going to do negative 18 divided by 6. When we do that, we get negative 3. Okay, so we got to pay attention. This is negative. All right, so let's go ahead and put this into our equation. So we have AN equals A1, which is 6, times our ratio, negative 3, to the power of n minus 1. If we look, okay, we got 11 as our n, so 11 minus 1. Okay, and let's go ahead and simplify. I'm going to go ahead and put my negative number in a parentheses just so I know. So I have times negative 3 to the power of 10. Okay, when you put a negative number into your calculator, put the parentheses around it. Okay, because that's going to tell us and help us if it's going to be a positive or negative number. When you put it in your calculator this time, you should get a positive number. And here's why. When your exponent, okay, when it is positive, okay, when it is even, your exponent is even, you'll have a positive number. When your exponent is odd, your answer should come back as negative. Okay, so since we have negative 3 to the power of 10, our answer this time is going to be positive 59,049. And finally, we need to multiply that by 6. And our overall answer is going to be 354,294. And that's what you would plug into your answer. You don't have to worry about the commas, okay? Just know that it's a big number. Sorry. Go ahead and look at this one on your own. Let's look at this one. All right, let's go ahead and figure out our ratio. So our ratio is going to be our A2 divided by A1. So that's going to be 6 divided by 3. When we do 6 divided by 3, our ratio is going to be 2. So let's go ahead and plug it into our equation. So we have AN equals A1, which is 3, times R, 2, to the power of n minus 1, or n is going to be 10. So we have 10 minus 1. Let's go ahead and simplify. 10 minus 1 is going to be 9. So in your calculator, you're going to put 2 to the 9th power. So this answer is going to be a little smaller. So we're going to have 3 times 512. When we do 3 times 512, we are going to get 1,536. And there we go. Biggest thing is just make sure you know those equations when you're plugging them in right, and just make sure you're reading if it's geometric or arithmetic.